I'm Pete Zelinski with Additive Manufacturing Media. We recently visited Freeform Technologies in St. Mary's, Pennsylvania. A contract manufacturer making parts through additive manufacturing, making production parts largely through binder jetting. We reported a feature article on this company. I will put a link in the video description. Here is a walk through their production process, the production steps in making scale production through binder jetting, along with a look at how these different steps are playing out for Freeform. Process development begins with measurement. An iterative measurement sequence at the beginning establishes repeatable production. I will have more to say about that later on, but the process in a very significant way begins and ends with measurement. The actual 3D printing is done on binder jet machines. Freeform has binder jetting machines devoted to different metals, multiple stainless steel alloys, as well as Inconel 718. We did a whole other video on binder jetting, how the process works, what it's used for. Check it out. I will put a link in the video description to that as well. One of the strengths of binder jetting for production is the ability to nest production quantities within the binder jetting build volume in 3 dimensions. Freeform does this, but they nest parts only to a certain point. One thing that they will not do is utterly cram and optimize the build volume by putting parts in different orientations to kind of jigsaw them together within the build volume, get the most possible parts in. Freeform won't go that far just because they are devoted to production, to repeatable production. Their view is put parts in 2 different orientations, and that becomes one more variable that could potentially result in differences part to part. They don't want that. So they use nesting to get production batches into a single build, but within nesting, every single part has to be in the same orientation for consistency. After binder jetting comes curing. Curing takes typically 26 hours. So, simple part of Freeform's process, always get curing started early in the morning so that it's done and the parts are ready for the next step the morning of the following day. Next is depowdering, which is the most manual step in the process. Depowdering is done in a separate room with separate pressure to keep the powder contained. Freeform freely acknowledges right now depowdering is the bottleneck in the flow of production, and they're looking at that. In order to get the entire production sequence flowing more quickly, one possible development that is very likely to happen, they will probably find ways to bring more automation to this step, to depowdering. Then sintering. A sintering furnace like this has the capacity to hold oftentimes a month's worth of binder jet production for a given part all at once. When we were looking at the sintering cycle they were preparing to run, it contained a couple different 1,000-piece runs of binder jetted parts, along with 100-piece batch, along with various lower quantity parts that were part of part and process development that they were doing. All of that sintered at once. The sintering cycle takes less than 24 hours. Next comes tumbling. Not every customer asks for tumbling, but Freeform routinely does it anyway, because that layer line surface texture that is typical of additive manufacturing, it is a different looking surface and finish relative to what a lot of buyers of production metal parts are accustomed to expecting. So it is pretty easy to address. Through a tumbling step, Freeform can give its binder jet parts a smoother finish, a more aesthetically pleasing finish. So it's a pretty routine step. Then inspection. 3-dimensional inspection like this is not only the way parts are validated, but it is the way the process is developed initially. The Live Sinter software that Freeform uses, and it's part of its desktop metal binder jetting system, what it does is it takes 3D measured forms of sintered parts looking for distortion that sintering might have induced, so that the software can compensate by pre-distorting the 3D printed geometry with the aim that the post-sintering geometry will come out just right. During process development, it generally takes multiple iterations of producing parts, sintering them, investigating them in Live Sinter, and then compensating them. And then once they've dialed in the process that way, ongoing 3D measurement like this is how they validate and assure that they continue to have repeatable production.